Okay, everyone, more videos. As you can see, I have a new shirt on today. It says, "A day without math is like," well, I don't know, just kidding. I have no idea. And so that's kind of the way it is. Today it's Sunday, and again, I'm doing math videos for my geometry class. This is wonderful and marvelous. Today we're going to start with volume. Now, volume is a really interesting thing. Volume is the amount that is inside. So how do we find out the amount inside a shape, a three-dimensional shape? That's what we're looking at, is the amount inside. So to find the amount inside, we have to start with what is called cubes. You see these little cubes? These are 1 unit cubes, whatever the size of the unit is. So we start putting them inside the box. I put them all together, and we have layer upon layer of these cubes in this box. And how many high is it? Well, each strip is 9 units long, and there's 4 strips in a row. So I have 1, 2, 3, 4, 6 rows. There are 6 rows of these cubes in this box. So we have 6 rows or 6 levels. That might be better said that way. 6 levels high. And we have 9 cubes long in each string, and there's 4 strings to a row. On each level. That's the best way to do it. So how many cubes are there in this box? Well, we have to multiply 6 times 9 times 4. And as long as it's a prism, it's easy to think of that, especially a rectangular prism or a square prism. It's easy to think of it as length times width times height is an easy way to think of volume of a prism, okay, as long as they're rectangular prisms. So you've got 54 times 4, which is 16, 21. So we have 216 cubic units, or we can write it units to the third. And the reason why is we're counting cubes. So just like in area, when we were looking at the first half of the course where we had perimeter and then we had area, the area of a flat surface, you counted in squares. Now you're looking at the volume, which is the amount inside a three-dimensional shape, and so you count it in little cubes, which is why we use that little 3 as a power as a shortcut to do that. So as we look at these, we need to look at exactly what's going on here. So volume again is the quantity inside. Inside the three-dimensional shape. Or solid. That's a better word for it. Okay, the quantity inside the three-dimensional solid. All right. For prisms and cylinders, the volume of the shape is equal to the area of the base times the height of the 3D shape. For prisms and cylinders. For spheres, That's like a ball shape. These have a unique, it's 4 pi r cubed, the radius cubed, divided by 3. Okay? For pyramids, your volume is the area of the base times the height of the pyramid, and then divide it by 3. Okay? So we have all these various kinds. You have, for prisms and cylinders, the volume equals the area of the base times the height. For spheres, it's 4 pi r cubed divided by 3. For pyramids, it's the area of the base times the height divided by 3. And if I had the small ones here, the small 3D shapes, I could actually show you. What we're talking about here is like this. This is a square prism. Now, the volume of this pyramid, which is the same size in the base as the base of this square prism, this pyramid, and it has exactly the same height as this pyramid, this thing has 1/3 of this. In other words, if I had a bowl of water, I could fill this thing up 3 times, pour it into here, and it would take 3 of these to fill this, okay? So that's the relationship between these. They very definitely have a strong relationship. So, the area of the base times the height. For spheres, 4 pi r cubed divided by 3. For pyramids, the area of the base times the height divided by 3. Now, when we did surface area, we talked about slant height versus height. Slant height is the height of the side, the height of the triangle on the side in the pyramid. The height of the pyramid itself is from the middle of the base to the top of the peak. That's what the height of a pyramid is. So you have a slant height, which is the height of the triangle, versus the height of the pyramid itself. Okay, so that's important to understand that. The same thing is true of cones. This cone, I could fill it 3 times, and it would fill up this cylinder, which is exactly the same size circle and the same height. And again, the height of this cone is from here to the middle of my circle, whereas the side of the cone, this would be called the slant height of the cone. So it's important to understand those distinctions that are going on here. Okay. Since the measure of a cube, every one of the measurements are the same, the cube is an easy prism to do the volume of. So, a cube, volume of a cube is equal to side times side times side, which is s cubed. Volume is easier than surface area, guys. It's easier to keep it all straight, okay? The volume of a rectangular prism is equal to length times width times height. Okay, the volume of a cylinder is equal to the volume of the base, the area of the base, which is pi r squared, times the height of that particular cylinder. Okay? We're going to do some of these after a bit. Okay, volume of the pyramid. Let's do a cube first. The volume of a square pyramid is equal to side times the height divided by 3. Okay? Volume of a rectangular pyramid is length times width for the base times the height divided by 3. Volume of a cone is equal to pi r squared for the base times the height divided by 3. You see how those are related? Volume of a cone is the volume of the cylinder divided by 3. Volume of the rectangular prism is the volume of the rectangular prism divided by 3. And the volume of the cube is the volume of that, well, since the height is s, it's s times s times s divided by 3. So all of those are related to each other, which is kind of nice. If you learn one, just remember divided by 3 and you'll get the pyramid that relates to it. So that's really important. So let's do some work with this. Okay, I have a rectangular prism that has a base of 6 feet by 8 feet and a height of 10 feet. So if I were to draw this, if I can draw my base, feet by 8 feet, and then we're going to go up for the height. $10. That kind of gives you an idea of how to draw it anyway. So we have 6 times 8 times 10 is going to equal 480 cubic feet. Okay. Now I have a cone with a radius equal to 10 feet and a height equal to 25 feet. Okay, so let's draw that. There's my circle with my radius of 10 feet and my height of 25 feet. This is 25 feet high. Okay, so pi times r, which is 10 squared, times 25 divided by 3. Okay, that's what my volume will equal. So V is equal to 3.14 times 100 times 25 divided by 3. So let's see what that is equal to. 314 times 25 divided by 3. And this is equal to 2,616.67 cubic feet. So as you see, it gets pretty big, doesn't it? A lot of cubes would fit into that kind of a pyramid or a cone. Okay, the volume of a sphere. So let's look at a sphere now. So here's my sphere. And my sphere has well, let's do a radius first. My radius is going to equal, let's do 10 meters. Okay? There's my radius of my sphere. So remember, volume of my sphere is equal to 4 times pi times 10 cubed, because that's my radius cubed, divided by 3. Okay, so volume is equal to 4 times 10 cubed is 1,000 times pi divided by 3. So that's going to be, let's get the calculator out. And these you will want to do with your calculator. And I'm just using 3.14 as my pi. So this is equal to 4186.67, and that is meters cubed. 4,186.67 cubic meters. So these are much easier to calculate than your surface area. But we can also make them complex, and we can compile them together. So let's look at something like this. Green bin. Okay, we've got a green bin. Well, most of the green bins around here are big cylinders with a sphere on the top, or a half a sphere. And then we're going to put half of a sphere on top of that. Okay? So, let's do a, let's see, oh, I don't know, 10 meter wide maybe? Let's do a 5 meter radius. So the first thing we have to do is analyze what are my two shapes. I have a cylinder and I have half of a sphere. So we have a cylinder plus 1/2 of a sphere. So this tells us what formulas we're going to use. My cylinder, oh, I need a height on this. Let's make it 15 meters high. Okay? So my cylinder is going to be, my volume of the cylinder is pi r squared times my h. So this is pi times 5 squared times 15. Plus, my sphere is 4 pi r cubed over 3. So this would be plus 4 times pi times the radius, which is 5, cubed, divided by 3. Okay? So what do we got here? Well, just keeping pi, I've got 5 squared, which is 25. So 25 times 15, oh, I could do it in my head, but I'm not going to. 25 times 15 is going to be 375 pi plus 4 times 5 cubed equals 500 pi divided by 3. Okay, so adding that together, I have 375 plus 500 over 3 equals 1625 divided by 3, which is going to equal 541.67 pi. Okay, now we're going to multiply that thing times pi. And I'm going to use the pi button this time to see what it gives me. And I end up with 1701.696, and this is cubic meters. Okay, so you see, you add your pieces together just like you do in finding area of a flat surface. You look at your shapes of your 3D, and then you add those shapes together. So we can do a lot of different things with these. Let's look at another one. We can do the same thing with this that we do with our area of a circle, where you might put a shaded area between. Okay, so this is going to be a cylinder inside a cylinder. So here's my big cylinder. And then my little cylinder. And all around the outside of this is shaded. Okay, a big cylinder around a little cylinder. Okay, so we're going to have our big cylinder minus the little cylinder, just like when you had a big circle minus a little circle. It's the same idea. So let's put some radiuses on this thing so we know what to do with it. Okay, radius of my big cylinder is 10 feet. Radius of my little cylinder is going to be 4 feet. And the height of my cylinders is 30 feet. They both have the same height. So now let's look at this. My big cylinder is pi times my radius, which is 10, squared times my height, which is 30. And my little cylinder is going to be pi times my radius, which is 4 squared, times my 30. Okay, so 100 times pi times 30. So let's go 3,000 pi minus 16 times 30 is 480 pi. So this is going to be 2,520 pi. No? Yeah. Which is then equal to 7912.8 cubic feet. You just have to multiply it out, and I use the 3.14 for pi. Okay, so you see how that works. It's really nice that it works so well. Okay, so you're going to see things like that in your homework as you look at this. You can have fun with these, guys. Okay, we are going to do one more problem, I think. And this one, we're going to look at a hexagonal prism. Okay, a hexagonal prism, a regular hexagonal prism with a side of 10 centimeters and a height of 15 centimeters. Okay, and this is my 15 centimeter height. These that are inside need to be dashed. There we go. There's your hexagonal prism. 3D is hard to do. So, what is the volume of that hexagonal prism? Well, it's the area of the base times the height of my pyramid, of my prism. Okay, my area of the base means we need to know the area of this hexagonal prism, this hexagon in the bottom. So, let's go back to what a hexagon is. A hexagon has 6 equilateral triangles. Okay, so we're going to draw one of them. Right here, here. And we need to know the height of this hexagonal triangle. And do you remember what that is? The height of a hexagonal triangle is equal to what? Well, it's going to be half of the base here, because we're going to have to do half of 10, and this is 10, so we're going to have to use that Pythagorean theorem, and you're going to get 1/2 times 10, which is 5, so we'll just put it 5. 5 squared plus h squared is equal to 10 squared. So this is 25 plus h squared is equal to 100. So h squared is equal to 75, 100 minus 25. So h is equal to the square root of 75, which is 25 times 3. The square root of 25 is 5, and square root of 3. This is the exact amount. Okay, so my height of my hexagon, of my triangle, is 5 square root of 3. Now remember, the area of that triangle is going to equal 1/2 times the base times the height. So this is 1/2 times my base, which is 10, times my height, which is 5 square root of 3. And that's one triangle, so this becomes 1/2 of 10 is 5. 5 times 5 square root of 3, which is equal to 25 square root of 3. Now, that's one triangle. Now, to get all of those, it's 6 times that. So 6 times 25 square root of 3 will give me my area of my base. So that's going to be 6 times 25 is equal to 150 square root of 3. Now, we've got the area of our triangular, of our hexagonal base. Now we have to multiply that times the height of my prism. So 150 square root of 3 times my height, which is 15. Okay? And we'll grab that calculator again to make it easier. So 150 times 15 times my square root of 3 is equal to 3,897.114, and we'd round it probably just to 3,897.11, and this is centimeters cubed. So we have a lot of stuff when we put it all together, and you can do all kinds of things with these volumes. Okay, to recap, let's see. I think we'll finish that one with that and then start another video. Okay?